Alright, so let's go ahead and continue with the notes from yesterday regarding the second fundamental theorem of calculus. Alright, so we got this graph here. They told us it was called g of t. And they're telling us that f is represented by the integral from -4 to 2 of x of g of t. So could I use this graph to calculate this integral? Yes or no? Could I use this graph to calculate the integral here that I want? We don't know what 2x is, but I mean like in general, if that was a number. Yes, why is it that we can use it to calculate that integral? Because it is the graph of that function that we want to integrate, right? We can find the bounded space. So it's one thing to remember. Sometimes they give you like g prime here, then would I be able to use this graph for that? No. Okay, I would have to use the first fundamental theorem of calculus and work with that. You understand? Alright, just reviewing stuff. So the first question says find f of 0. So if they want f of 0, that means I put 0 in for the x. So that would be the integral from -4 to 2 times 0 of g of t. So 2 times 0 is what? Is 0. So technically we're looking for the bounded space from -4 to 0. Okay, so we're going from here, which is this space, all the way to 0, which is here. So it's going to be this space, then we're going to have this space here, and this space up here. Doesn't this picture look familiar from sometime in the past? Yeah, wasn't it on your test recently? Yeah. It was on your test? Oh, cool. Okay, so what do we know about these two spaces here? Alright, what's this area of this guy? 2. This is how much of a circle? 1/4 or 1/4, right? So that would be 4 pi divided by 4? Pi. Okay, so that means that the value of this integral from -4 to 0 would just be 2 plus pi or pi plus 2?
Yeah.
Which one's right? Both.
Yes.
Very good. Okay? How about the next one, f of 2? That one wants me to do the integral from -4 to 2 times 2. Bless you. G of t dt. So 2 times 2, Daniela, is how much? 4. Very good. So we're going from -4 all the way to +4. So we want the whole thing, right?
Yeah.
Oh, okay. What do we know about these pieces over here? These guys are also going to cancel out. So technically it's this part right here, how many times?
Twice.
Twice. So that's 2 plus 2, that's what? 4. And pi plus pi? 2 pi, so it's really just 4 plus? Oh, geniuses. Easy? Alright, now we get to the part where it says f prime. Oh my goodness. F prime at 1. In order to find f prime at 1, I would need to know what f prime is, right? So what would f prime of x be? How would I get the derivative of this integral? Second fundamental theorem of calculus, right? Plug in the top limit. So that gives us g of 2x times the derivative of the top limit, which is 2. Minus, plug in the bottom limit times the derivative of the bottom limit, which we know is going to be what? 0. So we're skipping that part. You understand? Know that that's what you would have to do if that had a variable. Alright, so now we can find f prime at 1. That's going to be g of 2 times 2. I did the 2 times 1 in my head. Are we okay? Yes? You're not going to freak out and be like, where'd you get that 2? Okay, so what would g of 2 be? How would I get g of 2? I just go to the graph and now I'm looking for a function value, right? So at 2 it's 1. So this is really 1 times 2, which equals 2. Again, you can do that part in your head. with me, Polly? Alright, try this one. So we already have a formula for the derivative, right? And that was g of 2x times 2. You saw how I didn't tell you to use it? You just had to know that you had to use it. Why did I write that again? I'm sorry. That should be f prime of negative 2. That's going to be g of negative what? 4 times 2. So again, use the graph to figure out the function value at negative 4. What is that? Negative 1 times 2 we get? Easy? Orale, second derivative. Well, we already know the first derivative, don't we? That was 2 times g of 2x. So what would the second derivative be? 2 times g prime of 2x times 2, right? Chain rule. So that's really 4 times g prime of 2x, right? Now we need to evaluate that at 2. So we want f double prime at 2. That's going to be 4 times g prime at 2 times 2. 4? How am I going to get g prime at 4? Look at the graph. So I want g prime at 4. What's g prime at 4 again? It's going to be the slope of the tangent line at that number, right? We're not getting negative 1 because it's negative 1 here. We're getting negative 1 because we're figuring out the slope of that piece, right?
Yeah.
Do we understand? So maybe that was a bad example. I should have dropped it further down so the function value would not equal the slope and then you get confused with that. But this should be negative 1 times 4, which is negative 4. Now some people would argue that. Why do you think some people would argue that answer? Because it's at an endpoint? And what's the problem with that? The derivative at the endpoint? Why can't we find the derivative at the endpoint? Because the limit doesn't exist? Yeah, so this is like a point of discussion, right? A gray area? So are you a purist or a non-purist? If you do what we did here, you're a non-purist.
So we're all not quite. We're not purist.
If you were a purist, then you would say that it is undefined, the second derivative at 2. Why would we say that it would be undefined? Because there's no g prime of 4. Why is there no g prime of 4? Why is it not differentiable? Because it's not continuous at 4. Because g of t is not continuous, right? So you want to write that? Some argue, right?
Are we gonna write something AP says?
Either one would be correct, right? If they would present this problem on the AP test. That's why they wouldn't give you something like that. But like on my stuff, like on the homework, if you did this, I would accept it. But also if you told me what you were going to write down here, I would also accept it. It's just two different perspectives. Right? So some argue that g of t is not continuous at t equals 4, right? Therefore, g prime of 4 does not exist, so f double prime at 2 is undefined.
So would that be the case if you have to do g prime?
No. At g prime of 2,
stuff like
Well, actually, yeah, that would also be the case, but the reason would be different.
Yeah.
It is consistent.
Right, the reason would be because there's a cusp there. Okay?
Brandon.
There's gonna be an example like that coming up. But yeah, I like the way you're thinking.
Carlos said
Got the hang of it? Are we good? It's too easy? Ready for the assignment? Yes or no? Practice a little bit more? Alright, so what is this the graph of? F of t. Is that what we're integrating?
Yes.
Alright, they're calling it g of x, so we can use this graph to figure that out. We want g of -6, so substitute it for x in the problem. So we're going from -1 to -6 of f of t dt. What's the problem there?
Switch it and put it in.
Oh, we're going from from -1 to -6, so that's backwards, right? Okay, so we can fix that by switching the limits and negating the integral, right? Now we're gonna go from -6 to -1. I always wanna go from left to right. Small to big. Okay, cool. So we can use this graph to calculate that integral by finding the bounded space from here. So we want this guy, right? What's the area of that triangle? 2 times 4 divided by 2? 4? Okay, we also want the area of this trapezoid, right? Up to -1. So base 1, that's 1, 2, 3, plus base 2, 4, 5. Times the height, 5 times 2, 10, divided by 2. This is -5. Okay, so 4 plus -5. So negative times -1, that gives us what? Positive. Are we okay? Let me show how we got this. 4 minus 5. Good? Okay? Yeah? A lot of awkward looks. How about g of 6? Now we want to go from -1 to 6, right? Now we're doing the other part from here all the way to here. So let's do this trapezoid on the bottom. Base 1, 1, 2, 3, 4, 5, 6, 7, 8, right? Times the height, 2 divided by 2, -8. And then we want to go only up to 6. So how much of that circle is that? 1/4, right? So pi r squared, so that's 4 pi divided by 4? Pi. What would the answer be from from -1 all the way to 6? Pi minus 8. Easy? The next one wants g prime of 6. So let's find g prime. We know g of x is this. -1 to x of f of t. So what would g prime of x be? Plug in the top limit times the derivative of that limit. 1, right? We don't worry about the bottom one because it's a constant. Right, so we know g prime of x is equal to just f of x. So if I want g prime of 6, all I'm looking for is f of 6. What would that be? Go to the graph, go to 6, and the function value is 2. If I want g prime of 2, that's equivalent to f of 2. So go to your graph, go to 2, and what do we get? -2. So far so good? The next one's asking for g double prime. So we know g prime is f of x, so what's g double prime gonna be? F prime of x. So if I want g double prime of 2, that would be like me looking for f prime of 2. So the slope of the tangent line at 2 on the graph of f. So if I go to 2, and I try to draw a tangent line there, which slope would it be? Would it be this positive one or this 0? You can't decide, right? Because there's such a quick change. Okay, so what would it be there? Undefined. Okay, now we have to provide a reason for our answer, so what would be the reason? Because f of t has a cusp at t equals what? The second one's g double prime at -4. So g double prime at -4 is equal to f prime at -4. Now I go to -4, Paulina, and I'm pretending I draw a tangent line there. And what's the slope of that little tangent line? -2? 2 down, 1 to the side? Yep, -2. And we don't have to provide a reason for that. I just put that there so you wouldn't automatically know that it was going to be undefined. Cool? If you wanted to provide a reason, then you could say, because that is the slope of the line, right? Slope of f of t at -4. Cool? One more? Just to finish it off, since we have time and we're on a roll here.